Good morning. My name is Jaques Reifman. I am a senior research scientist with the U.S. Army Medical Research and Development Command, where I lead a group of scientists in predictive analytics. We develop mathematical tools to address military medical relevant research for our warfighters. Today I'm going to share with you an app that we developed called the To Be Healthy, which we use to continuously monitor the physiological status of our service members. The app compares the current vital signs of the service members with vital signs collected during a baseline period where we know that the individuals were healthy, and when the app finds a discrepancy, then it provides an alarm indicating an abnormal state of our service member. The app, the To Be Healthy app, consists of two components, a hardware component and a software component. The hardware component consists of commercial off-the-shelf smartwatch, where the watch collects heart rate and activity data. That data are continuously transmitted in real time to a smartphone where the software resides. The software is based on a Bayesian learning algorithm. And essentially what the software does is compares the heart rate at the current time with the heart rate collected during the baseline period for the same time of day, for the same activity level as at the current time. And then over number of minutes, when the app determines that there is a consistent deviation between the heart rate collected now and the baseline period, accumulates enough evidence, and then provides an alarm indicating that the service member is in abnormal state. To develop and assess the To Be Healthy app, we used a control human malaria infection study where we infected 10 volunteers with malaria. We continuously collected vital sign data for 6 weeks, 2 weeks prior to the infection, which we used to establish the baseline data, and 4 weeks after the infection, which we used to assess the app. The data were collected using the smartwatch. As you know, malaria has a 10-day incubation period, so after 7 days post-infection, we ask individuals to report to a hotel where we monitor them closely and drew blood so that we can use a gold standard blood assay to assess if the individuals had parasitemia. Based on the gold standard blood test, 9 out of the 10 individuals infected with malaria tested positive for malaria. 1 did not. Using the app, the To Be Healthy algorithm, we're able to determine that 7 out of the 9 individuals indeed had abnormal vital signs, indicating an 80% sensitivity for detection of malaria. Importantly, 6 out of these individuals showed an abnormal vital sign on average 6 days before the gold standard blood test, indicating that indeed the app is capable of an early indication of a malaria infection. For the one individual who tested negative for malaria, the app correctly indicated that the individual physiological status was actually normal. The beauty of our study is that we used control human infection study, which unlike other studies to determine the feasibility of using wearables for infection detection, here, because it was a control study, we knew precisely when individuals were infected, we knew precisely when the individuals tested positive, which then allowed us to uniquely determine the feasibility of using wearables to collect vital signs for infection detection. Currently, we are prospectively validating the To Be Healthy in a new human control infection study with a different agent. I'd like to thank you for taking the time and listening to my presentation.